Welcome grade 8 to our math video on translation today. So translation is another way in which we can think about how a shape can move on a grid or on a graph. We talked last time about reflection and how we can mirror or reflect an object in a particular line. Well, today we're going to talk about translation, and what translation is being able to simply shift or move an object from one spot to another. It doesn't spin, it doesn't mirror, it doesn't do anything else except move. So let's take a shape. We're going to draw kind of a nice simple shape here that has 3 points, 1, 2, 3. And what a translation is taking that shape and moving it to another spot. It doesn't change how big it is or anything else like that. So if you see this length here, this goes from here to here, here to here, here to here. We're going to even label those. Let's say that's A, B, and C. And now we're going to move that. So let's move that to a new spot. Let's move that here. So again, if you take a look, this is our new spot for A, our new spot for B. You'll notice that they're the same distance apart. This is our new spot for C. It's still 2 spaces higher, and then they connect. This shape is exactly the same as this triangle shape here. It's just in a different location, and that we call a translation. Now, when we're working with translation, what we're interested in is how did we get from this shape to this shape? And this is called describing a translation. And when we describe a translation, we're basically asking how far did it go in the x direction and how far did it go in the y direction. Remember that the x direction is left or right, whereas the y direction is up or down. So when we're describing something moving to the right, we think of that as a positive number. When we're describing something moving to the left, or we're describing it as a negative number. So this way is positive, this way is negative. For the y direction, if something is going up, we describe that in the positive direction, or down would be in the negative direction. So let's take a look at our shape here. We could take any one of these points. It doesn't matter which one we decide to take a look at. So let's start off by taking a look at point A. Well, in order to get from this point A to this new point A, we kind of think of there being kind of an imaginary line here, an imaginary line here. I'm looking at how I got from this spot to this spot. And if we take a look, I'm moving to the right, which means that my x value, or moving in the x direction, is going to be a positive number. And how far over did I have to move? Well, let's see, 1, 2, 3, 4. So we would describe that translation. That translation is that we are going to move 4 in the x direction. Move 4. And notice how that's a positive 4 in the x direction. And let's take a look at our y. Now y is going from this point here to this point here, from our A to our A. We are moving down now. So down is actually going to be a negative move in the y direction. But let's see how many spots. 1, 2, 3, 4, 5. So we are going to move -5 or -5 in the y direction. So this would be how we would describe the translation for triangle ABC to triangle A0, B0, C0, or this version or the image of this triangle after the translation has taken place. Let's take a look at another example and see how we can figure this out using coordinates. So here we have another grid we're going to deal with another triangle here again. Again, something maybe a little bit easier to work with. We're going to also talk about this being a triangle A, B, C. But now we're going to start thinking about the coordinates that are at these points and what happens to these coordinates. So, coordinate A, where is coordinate A? Remember that when we're dealing with coordinates, we always have our x value first and our y value second. Remember that x is, again, how far left or right we are on our x-axis. And y is how far up or down we are on our y-axis. So point A here on the x is 1, 2, 3, 4. That's where it is. And our y, it's 1, 2, 3. That's where it is on the y-axis. All right, our point B is at 5, 1. And our point C is at 1, 1. So we're going to go through a translation here, and this time I'm going to give you the translation. I'm going to tell you what it's going to be, and we're going to figure out how to get there. So the translation that we're going to follow is going to be -4 in the x direction and a -1 in the y direction. So automatically when we see -4 in the x, I know that I'm moving left and not right. When I see -1 in the y, I know that I'm moving down and not up. It doesn't matter which point we decide to start at. So let's take any point here. We'll take point C. We'll work with that one. It doesn't matter if we did this to every single point, we'd end up in the same spot. So point C, we're going to move -4 in the x direction, 1, 2, 3, 4 to the left, and -1 in the y direction, -1, and I have my point right here. This is my new point C. Let's do the same to the B. -4 in the x, 1, 2, 3, 4 in the x direction, and then -1 in the y direction. Perfect. There's my new point B. A, let's do the same thing. 1, 2, 3, 4, down 1. There's my new point A. All I have left to do is connect the dots. And now I have my translated shape from here to here. I can see that translation and all of the points moved in the same direction and at the same magnitude. Let's take a look at what happened to the coordinates of our new points. So A went now to our new A location, our image location for A, which is going to be at 0 for the x and 2 for the y. Let's take a look at B. Our new location for B is at 1 on the x, 0 on the y, and our new location for C is at -3 on the x and 0 on the y. Now, this is really interesting because yes, we went through all this work. Yes, we graphed all this information. But in order to figure out where the new shape was, we actually didn't have to graph anything. Using this bit of information here, we could have gone from these coordinates to these coordinates without having to graph a single thing. Remember that all of these numbers are our x values, and all of these values are our y values. This was the instructions for what we had to do to each. So if I take the x value here, which is 4, and I take the instructions -4 to that x, I get my new x value of 0. If I take 3 and -1 for my y, I get my new y location of +2. Same with these. 5 minus 4 is 1. 1 minus 1 is 0. 1 minus 4 is -3. 1 minus 1 is 0. And so whether we're working with just coordinates, whether we're working with a graph, or whether we're working with translation directions, we're able to figure out how we get a shape or how we get a point from one location to another in this graph or grid coordinate system.